At state 0, north-south is green and east-west is red. So there is a sensor on the east-west direction. So as long as the sensor is not detecting a vehicle, then it will remain at state 0. As soon as it detects a vehicle, and at the next rising clock edge, it will go to state 1, and that begins the traffic light as it to change colors. So state 1, north-south is yellow, and here to go from state 1 to state 2, it doesn't matter what the sensor is detecting at this point, because traffic lights will go through the motion regardless of what the sensor is detecting. So at state 2, both traffic lights, north, south, and east, west, are both red. So all traffic is stopped to ensure that there's no accidents occurring. So then for state 2 to state 3, east, west is now green. And then at state 4, east, west turns yellow. Then at state 5, east, west turns red again. And then it goes back to state 0 to turn on the north-south traffic lights to green. For our code, I created a component of the finite state machine. And for my top level, we'll start on that for a little bit. I have an east and west, which represents the sensors. And for these outputs, RNS, YNS, GNS, and so on, it represents the traffic lights. And so the first letter is the color of the light, and after that is the direction. So RNS, for example, stands for red, north, south. Right? And I created 2 signals. One is called T-lights, which will hold the output value from the finite state machine, and a signal for car east-west, which holds the results of east-west being ORed together here. Because we want to just have one input that controls the finite state machine, and the east-west traffic lights, they mirror each other. It doesn't matter if there's a car in either the east or west, as long as it doesn't matter if there could be one car in the east direction and no car detected in the west direction for the light to turn green. So in a finite state machine, I have here the clock and reset as my inputs, and the car east-west, car EW, as another input. And then T lights is my outputs. It's 6 bits, and at each bit holds the value of which lights are on. My signal in my architecture is CS and NS. CS stands for current state, and NS is next state. So this is the what controls my current state. So when reset is high, the current state will go to state 0 at 0, 0, 0. But if long as reset is low, it will follow the rising clock edge. So then my next state is what updates my current state. In this process block, I create a case statement. So at state 0, if car EW is 1, it'll go to state 1, or else it'll just stay in state 0. And then the outputs for T lights for state 0 is 0, 0, 1, 1, 0, 0. So here, north-south is green and east-west is red. So that's what the ones represent, is which lights is on currently. At state 2, oh, I'm sorry, at state 1, it'll go to state 2 because in order to go to state 0 to state 1, a car must be sensed at either sensors for the east-west direction. So then at this point, this is when the lights will now change from north-south is now yellow and east-west is red. Basically, the rest of my code will cycle through um, the same in such a sense that it will follow what my state diagram is for changing the lights in which states. And so let's go back to my top level. And so for my top level, the reason why I created a vector for T lights is because since I only care, so it would be easier, and I only care when there's a 1 at a certain place in the vector to change the lights. So here, my most significant bit for my T lights is represents the red for north-south lights, as well as the next one down is the represents the yellow for north-south, and then at the third index is green north-south, and then so forth. So for my simulation, as we can see that here currently east is 1, and it's still at state 0 because it won't change. So this is the beginning of the finite state. The finite state machine stayed at state 0 for a while as we ran it. But at this point, when we had input a 1 for east, until the next rising clock edge, it won't change to state 1. But here at state 0, we can see that north-south is green and east-west is red. So at the next clock edge, north-south is yellow and east-west is still red. Here, now north-south is red and east-west is still red. So no vehicles are currently moving at this point. And then this is when, at this point, at this next state, at state 3, north-south is red, and now east-west is now green. In state 4, east-west has changed to yellow, while north-south still remains red. And now both lights for north-south and east-west is now red. So no vehicles are currently moving. They're all stopped. And then it'll go back to state 0, in which north-south can now, cars for north-south direction can now go, and east-west is red.